Hello guys, welcome to the channel H2O, the A to Z of chemistry. So do you all students preparing for JEE and NEET examination fear inorganic chemistry? You do not like inorganic chemistry? You find learning of the reactions of inorganic chemistry very difficult? Well, if the answer is yes, you are at the right place. Why? Because we are putting up a complete playlist called as Inorganic Made Easy, where the lectures we are putting are going to be those lectures which are going to make the study of inorganic chemistry very easy for you. And the topics that are going to be in this playlist are all the topics which are very important for both JEE and NEET examination, questions coming up very frequently in these examinations. So please do watch the complete playlist Inorganic Made Easy. Along with that, there is one more playlist that I am putting up that is called as Quick Easy Tricks for Inorganic Chemistry. Again, it is going to be the same things, important concepts with very easy tricks which are going to be very helpful for your good scoring in JEE and NEET examination, because inorganic chemistry is going to be one thing which is going to make a difference between a topper and a medium scorer. Okay, so please do your inorganic chemistry very well. The first point that is very important for inorganic is that you should read the NCERT textbook. That is very important. But along with that, what are all lectures that I'm going to be putting up in this Inorganic Made Easy and Quick Easy Tricks, please do watch them. They are going to be really very helpful to you. Now, what are we going to learn in this lecture? Well, what we will be talking about today is going to be all inorganic reactions with water. So if you look at inorganic chemistry, be it hydrogen, S block elements, P block elements, D, F block elements, you will be finding so many reactions with water. Reaction of metals with water, reaction of non-metals with water, reaction of ionic compounds with water, reaction of covalent compounds with water. There are so many reactions and they are scattered throughout the whole of your inorganic chemistry text. So, well, we are doing up a compilation of all these reactions with water for you people so that the learning becomes really easy. And in fact, believe it or not, this is going to make up more than half of your inorganic reactions that we will be discussing with you in 3 lectures. Lecture number 1, that is today, we will be talking about the reaction of elements with water, be it the S block elements, the P block elements, the D block elements, the F block elements, be it metals, metalloids, non-metals. We will be talking about today of all these reactions, whether the elements they are reacting, not reacting, if they are reacting, how they are reacting. We will be talking about everything. So this is going to be a lecture which is going to be must for your JEE and NEET preparation if you want to good score in these examinations. So I hope you are going to be excited for your learning. I just want your notebook and pen so that you can just note down what all we are discussing. And it is not only going to be the reactions that we will be talking about. We will be talking about here and there the important concepts which in relation to these reactions is being asked in the examination. So it is going to be a real thorough preparation for you people from the topic reaction of all elements with water. And the next lecture that I will be taking over here, with water, we will be seeing how the ionic compounds they react, and the third lecture will be how the covalent compounds they react with water. And this will make what? This will make more than half of your inorganic reactions that you have to learn in a very easy way. Okay, so I hope you are excited. Okay, so let's begin. So what do we start this lecture with? Well, we will be starting this lecture with the first topic that you will learn in inorganic chemistry in class 11, and that is hydrogen. Now, does hydrogen react with water? Well, no, it does not. It does not react with water, but again, there are so many reactions in the chapter hydrogen of yours that are very important when we talk about the reaction of elements with water. Well, we talk about the preparation of hydrogen gas, and the preparation of hydrogen gas, we are going to learn the reactions of metals with water. When metals they react with water, they liberate hydrogen gas, and these become the very important reactions that you have to learn for today's topic. Okay, so here when we talk about the reaction of metals with water, there are going to be many metals present throughout the whole of the periodic table. We have the S block elements, we have the lower down P block elements, we have the D block elements, we have the F block elements, which are metals. And when they are reacting with water, what are they producing? That becomes very important for your testing in the JEE and the NEET examination. And for that, very simple it is that you have to first of all remember the activity series that you learn in your junior classes as well as in electrochemistry class 12th, right? So the electronegativity series that you have learned in class 12 is what you can see now on your screen. We have elements like lithium, potassium, barium, strontium, calcium, sodium. They are very good reducing agents. As we are going down this activity series, we find that the reducing nature that decreases. All the elements which are going to be above hydrogen, all of them, they can react with water. And when they will be reacting with water, how they will be reacting, we will be just now talking about that. And all the elements which are below hydrogen in this activity series like copper, mercury, silver, platinum, gold, well, they do not react with water. Okay, so first of all, one thing that you can learn from this activity series is which metals they can react, which metals they cannot react. Okay, so we have copper, mercury, platinum, silver and gold which do not react with water to liberate hydrogen gas. And above you can see there are various metals. As we are going down this activity series, the reactivity with water will be decreasing. The elements which are going to be above in the activity series, they can react with the water as cold water also when the temperature is not going to be very high. All right, and then as we are going to go down this activity series, we will have to increase the temperature of water. We will have to take hot water, and then we may have to take even steam for the reaction of these metals so that they can liberate hydrogen gas. Okay, so here you are going to learn many reactions in one go. And then once we have a general idea, we will be talking group wise of all the elements, how they will be reacting and what all is going to be very important for you people. Okay, so first and foremost, we have the reaction of metals with cold water when the temperature is going to be about 7 to 25 degrees Celsius. Here we have the metals which are very high in the activity series. They can react with water to liberate hydrogen gas. For example, we have sodium reacting with water to give us NaOH and along with that hydrogen, and this is going to be a very fast reaction. Okay, next we have is potassium. This reacts with water to form KOH and along with that hydrogen gas, and this is going to be an explosive reaction. Immediately it's going to catch fire. And next we have, for example, calcium. When this reacts with water, it will be forming calcium hydroxide along with that hydrogen, and this reaction is going to be a slow reaction. So I will be taking about the more details of these when we talk about one by one all the group elements, but in general all the elements which are high up in this activity series, well, they can react with cold water. And when they will be reacting with cold water, just remember, when an element is reacting with cold water, it is going to be forming the hydroxide, and along with that hydrogen gas will be released. Okay, so very easily you can remember, we have sodium reacts with cold water, it will be forming its hydroxide and hydrogen gas. Okay, the next we have is the elements which are going to be a bit lower down in the activity series, like we have magnesium, aluminium, manganese, zinc. They are not going to react with cold water, but they can react with hot water. Hot meaning from 25 degrees Celsius to about 90 degrees Celsius. And again, they are going to be liberating hydrogen. But when the water becomes hot, remember, it will not be the hydroxide that will be formed. It will be the oxide of these elements that will be formed. Cold water, hydroxide, hot water, or when we are going to go to steam, it will be the metal oxide that will be forming, and along with that hydrogen gas will be liberated. For example, we have magnesium reacting with water. It will be forming magnesium oxide along with that hydrogen gas. And then we have with steam, for example, the very less reactive metals like we have iron, nickel, cobalt, tin and lead, which you can see over here just above hydrogen, from iron, cadmium, cobalt, nickel, tin, lead. All of these, they will not be reacting either with cold water or with hot water. It is going to be a reaction with steam. And again, what will be produced? The corresponding oxide and hydrogen gas. For example, in case of iron, reacting with water, it will be producing Fe3O4 and along with that hydrogen. Now, Fe3O4 is called as ferroso-ferric oxide, and this is a magnetic oxide. Okay, so this is something important. And now we have a brief understanding how these metals they are reacting. Let us go group by group. So first of all, we talk about the group 1 elements, that is the alkali metals. The alkali metals, lithium, sodium, potassium, rubidium, cesium. Francium is going to be radioactive, so we will not be talking about it. In fact, when we will be talking about all these group elements, the last one we will not be discussing. They are going to be either radioactive, or these are the elements which have been synthesized artificially by man. So we will be talking about only the first 5 ones. Okay, so from lithium to cesium, we are going to see how they are going to be reacting with water. So I have already discussed that in the reactivity series also, that you saw that all the alkali metals, they are going to be the top of the reactivity series. They can react with cold water, and then they are reacting with cold water. What will be the product form? Yes, it is going to be the hydroxide, and hydrogen gas is going to be evolved. So we can just generalize all the alkali metals to be M. When they will be reacting with water, they will be forming the hydroxide. Hydrogen gas is going to be evolved. But what you have to, in addition, remember to this is going to be that, well, this reaction is going to become increasingly violent on descending down the group, which means that as we are going down the group, we all know that the size is increasing, the ionization enthalpies they decrease, the metals they can easily form the corresponding ions, and the reactivity is increasing, and it is increasing so fast, that as we are going to go down the group, the reactions they are becoming very, very violent. For example, when I talk about the reaction of lithium with water, it is going to be the least reactive. Okay. Then when we move on to sodium, it reacts vigorously with water. Now these are reacting with water. Along with that, they can also react with air. Okay, so oxygen of the air also they can react. So we want to store them in a safe place. And a safe place, generally we find that there are many non-metals which we can store in water so that they do not react with the air. Okay, but we have these metals, well, they can react with water very vigorously. So we cannot store them under water. Okay, so if we want to avoid their reaction with air, we cannot store them under water because they are very reactive. That is why we store them under kerosene. Okay, next we have is potassium. Now potassium, it is going to be reacting very fast with water. It is going to be immediately catching fire. The moment you put potassium into water, it is going to catch fire. And when we move on to rubidium and cesium, well, there is going to be an explosive reaction. It is going to be as if there is going to be a bomb bursting when you are going to put rubidium or cesium into water. Okay, so this is very important. Now, if you have noticed very carefully, what you will be finding is that lithium was on top of the reactivity series. Okay, you can just move a little back also, or in the upcoming slides, you will be seeing again once the reactivity series. So there also you will be able to notice that lithium is on the top of that activity series. Lithium is the strongest reducing agent that we have. But when we are talking about the reactivity of these elements with water, what we find is that lithium, this is even less reactive than sodium. You are going to see that lithium is least reactive to react with water. Okay. Now, why is it this so is very frequently asked in the examination. So you should remember this. Now I want you to look over here at the standard electrode potential values for lithium to cesium. What we find is that lithium, this has the most negative electrode potential value of minus 3.04 volt, whereas sodium, this has the least negative electrode potential value. Among all the alkali metals, it is minus 2.714 volt. From sodium to cesium, the negative values, they are increasing, and lithium, this is the highest. What this means is that lithium, this is the strongest reducing agent, and sodium, this is going to be the weakest reducing agent. But even then, what we find is that lithium, this is reacting with water less vigorously, even less than that of sodium. Now, why is it so? That is very frequently asked in the examination. When we are talking about the reaction of elements with water, this is something that you should remember very well. I have talked about this in detail in my lectures on S block elements, where we talk about in lecture number 4 the chemical properties of the alkali metals. So you can have a detailed understanding from there. Quickly, let us just talk about over here as well, right? So we have lithium to be the smallest of all the alkali metals. From the lithium metal, first of all, the first step has to be the breaking up of the lattice into individual lithium atoms. And for that, well, lithium, because it has a very small size, so it will be having a highest heat of atomization in comparison to the rest of the alkali metals. Next, because again lithium is going to be very small, removing of the electron from the neutral gaseous atom is going to require a lot of energy. So the ionization enthalpy of lithium is also going to be the highest. And then because lithium is very small in size, when we are going to put that neutral isolated gaseous now ion in water, well, the hydration energy is going to be immense because of the small size. Well, a lot of water molecules, they can get associated with it, and a lot of energy is going to be released, that is hydration energy. It is because of this exceptionally high hydration energy that we find that lithium, this has the highest electrode potential value. Okay, but if we have to first of all see how lithium is going to be reacting with water, well, it is not the hydration energy that is going to be accounted. Okay, then we are going to put lithium metal into water. The first step is going to be that it has high heat of atomization. The second step is it going to be having high ionization enthalpy, and because of that it has a high activation energy. Therefore, it is going to be very slow to react with water. It is going to be slow to react with water. As we are going to go down the group, the sizes are increasing, the heat of atomization is going to be less, the ionization enthalpies, they will be less, and therefore they are going to be very quick to react with water. But when we will be putting some other compounds in water, and then we are going to be seeing how these alkali metals, they react with those compounds, there this hydration enthalpy factor comes into being, and we find that lithium is going to be the strongest reducing agent. Okay, so I hope you will remember this very well. Lithium is the strongest reducing agent because of its high hydration energy, whereas it is going to be slow to react with water because it has a high activation energy. Okay. So now we move on to the group 2 elements, that is the alkaline earth metals, how they will be reacting with water. So one thing that you have to remember is that going down the group, just like the alkali metals, the alkaline earth metal reactivity with water will be increasing. So what we find is that beryllium and magnesium, they are kinetically inert to water. They do not have a tendency to get reacted with water. Why? Because of the formation of an oxide film on their surface. What we find is that beryllium, when this is going to be made to react with water, well, no reaction will be taking place. Be it cold water, be it hot water, be it steam, there will be no reaction. But when we look at the reaction with magnesium and water, what we find is that magnesium does not react with cold water, but it can react with hot water. And when it is going to react with hot water, hydroxide will not be formed. It will be the oxide that will be formed. Now, one very important thing that you have to remember here is that magnesium oxide, this is sparingly soluble in water. Therefore, a small amount of magnesium oxide, this will further react with water, and what we will be getting is magnesium hydroxide and hydrogen. So what you can say over here is that we have, first of all, the reaction of magnesium with water to form magnesium oxide. This magnesium oxide will be reacting with 1 mole further of water. So this becomes total 2 moles of water, and this will be producing magnesium hydroxide and hydrogen. So a small amount of magnesium oxide, this gets converted into magnesium hydroxide because magnesium oxide is sparingly soluble in water. One more thing that you can remember for magnesium hydroxide is that this is called as milk of magnesia, and this is used as an antacid. We will be talking more about in the next lecture when we will be talking about the ionic compounds reaction with water. The rest of the alkaline earth metals, they react with cold water, and when they will be reacting with cold water, obviously now you know that the product is going to be the alkaline earth metal hydroxide, and along with that hydrogen gas will be evolved. So here we have in general just written M, where M can be calcium, strontium or barium. When they will be reacting with cold water, they will be forming the hydroxide and hydrogen gas. So I hope now this is very clear to you. Now, one thing that you can remember over here is how beryllium hydroxide is going to be formed. So obviously it is not reacting with water to form the hydroxide. So well, how it can be formed is by the reaction of beryllium chloride with NaOH. So this will be forming beryllium hydroxide and NaCl. Next, we move on to the group 13 elements. First of all, we will be talking about the representative elements. We have talked about group 1, group 2, that is the S block elements. Now we are moving on to the P block elements. Then we will be quickly talking about the D and the F block elements as well. So we have group 13 elements, to be the boron family, and the first member boron, this is a non-metal. Then we have aluminium, gallium, indium and thallium, they will be metals. So boron, when we are going to see the reaction with water, what we will be finding is that boron also does not react with water or steam, but just remember that at a very high temperature it can react with steam. So when we are going to see the reaction of boron with steam at a very high temperature, just remember steam is formed at a temperature of 100 degrees Celsius, not at 100 degrees Celsius, but at a very high temperature. It is going to be reacting with steam to form B2O3, and along with that hydrogen gas will be evolved. So again, the product is very easy to remember because water over here is in the form of steam. So boron will be forming its oxide, and along with that hydrogen gas. The next we have is aluminium. So aluminium, this is a metal. So this should be reacting with water. But what we find is that aluminium does not appear to be reacting with water. And why? It is because of the formation of an oxide film on its surface. So once the oxide film has been formed, well, the further reaction will not be able to take place. That is why we say that aluminium does not appear to be reacting with water. But if the oxide layer is absent, yes, it can react even with cold water to yield hydrogen gas. Okay, so I hope this will be remembered by you people. And a very important application of this also, you can remember that why we are using a pressure cooker made of aluminium to cook food. How do we use aluminium utensils for cooking? This is because we have the formation of an oxide layer on the surface, the first initial use, and after that it is going to be safe to be used while cooking food with water. Okay. The next we have is gallium and indium. So gallium and indium, they also do not react with water unless oxygen gas is going to be present. And the last is going to be thallium. So thallium forms thallium hydroxide in moist air. So this was one thing that you have to remember, that thallium in reaction with water and oxygen, this will be forming thallium hydroxide in the +1 oxidation state. So generally what we are going to see is that the group 13 elements, they show +3 oxidation state as well as +1 oxidation state. But as we go down the group, because of the inert pair effect, the +1 oxidation state is going to be more stable. Therefore, thallium, when this will be forming its hydroxide, it will be in the +1 oxidation state. Now the next thing, thallium, this can also decompose steam at red hot. Fine. Next, we move on to the group 14 elements, that is the carbon family. So how they will be reacting with water. First of all, here what you can look at onto the left side is that carbon and silicon, they are going to be non-metals. Germanium is going to be a metalloid. Tin and lead, they are metals. So here in this group, you can see all non-metals, metalloids as well as metals, and how they are reacting with water. So first of all, we have carbon. So carbon, again, just like boron, this does not react with water when it is going to be cold, hot, or even with steam, but again just at a very high temperature, that is of 1270 Kelvin, well, it can react with steam. So the reaction that we have is carbon when it is going to be very hot. So just remember, this is going to be red hot coke reacting with steam at a very high temperature of 1270 Kelvin to produce carbon monoxide and hydrogen. The mixture is called as water gas. So again, it is very easy for you people to remember that it is steam over here. So the oxide has to be formed. But which oxide? It has to be carbon monoxide and not carbon dioxide. This is what you will have to remember. And this is very important for the industrial preparation of hydrogen. You have learned this in the preparation of hydrogen. This is the Bosch process. And water gas, very frequently asked, what is water gas? And water gas is also called as syngas. Why it is called as syngas is because this can be used for the synthesis of many organic compounds. For example, the starting product is going to be methanol, CH3OH. So this is going to be again a very important thing that you have to remember. Okay. So carbon monoxide and hydrogen is formed by the reaction of carbon, red hot coke with steam at a very high temperature. The next we have is silicon and germanium. They are also not affected by water at ordinary temperatures, whereas tin, this can decompose steam to form hydrogen gas. So again, it is going to be steam. So can you tell me what will be the product form? Yes, it has to be the oxide of tin. So we will be having the reaction of tin with water in the form of steam to be giving us tin oxide, and along with that hydrogen gas. The next we have is lead. So lead also does not react with water because of the formation of an oxide film on its surface, and that is why lead pipes were used for the transport of water. One more important thing as an application that you can remember is that tin is often sprayed as a protective layer on iron cans to prevent the can from corroding, because again, tin is not reacting with cold water. It is going to be just reacting with steam, and iron, this is very prone to corrosion. So you can use tin to spray on the iron cans as a protective layer. The next we move on to two groups together now. So first of all, let us quickly talk about group 15 elements, that is the nitrogen family. Nothing much to discuss over here. Pure elements in this family, they do not react with water. What we see is that the compounds of nitrogen, like this nitrates and nitrites, as well as nitrogen, this can dissolve in water. They are soluble in water, but they will not be reacting with water. Okay. Similarly, the group 16 elements, the oxygen family, here again the pure elements in this family, they will not be reacting with water. Next, we move on to the group 17 elements, the halogen family. All the halogens, you all know, they are the most electronegative elements in their respective periods, so they are very reactive. The reactivity towards water is going to depend upon their different electronegativity values. So how they will be reacting with water, this is going to depend upon how electronegative they are. And all these things that we will be discussing now, they are going to be very important for your examination. So first of all, we have the reaction of fluorine. So fluorine, well, this is more electronegative than oxygen. So here, please do remember, when fluorine will be reacting with oxygen gas, it will not hydrogen gas that will be going out. Okay, so fluorine being more electronegative than oxygen, it can displace oxygen from water. So what we will be seeing is fluorine on reaction with water, this will be displacing oxygen. There will be liberation of oxygen gas, and along with that HF is going to be formed. So it is going to be the ionized form that you will be seeing H ions and F ions in the aqueous solution. And along with that, oxygen gas being evolved. The next we move on to the rest of the halogens. So all of them, they will be less electronegative than oxygen. So obviously oxygen gas is not going to be evolved. So what is the product here formed? Again, it will not be hydrogen gas. Just remember this very importantly, because it is going to be the different behavior of halogens only that you will be seeing from the rest whole of the non-metals, metals as well as metalloids. So they will be reacting with water to form hydrohalic acid and hypohalous acid. For example, if I talk about the reaction of chlorine with water, this will be forming hydrohalic acid, that is hydrochloric acid HCl, and hypohalous acid, that is HOCl, hypochlorous acid. So chlorine on reaction with water, this forms HCl and HOCl. Now there is very importantly a way in which you can remember this as well as and understand the mechanism of reaction of how this reaction is being carried on. So here what we have is we have a chlorine-chlorine bond. Okay, so chlorine-chlorine bond. And water, we can understand this as a polar molecule. So we can have hydrogen to be dissociating as H ions and OH ions. Okay, now chlorine, this is non-polar, but what you can remember is that there can be an instantaneous dipole developing at any time. An instantaneous dipole is that one time there can be that the electrons, they are more towards one of the atoms and there is an electron deficiency on the other atom. So as a result, what we will be seeing is a partial positive charge on one of the chlorines and a partial negative charge on other chlorine. And it is at this point, well, this can be reacting with water. All right. So H positive and Cl, which is having a partial negative charge, well, they can be combining with each other and that will be forming HCl. And when this Cl with a partial positive charge will be combining with OH negative, it will be forming HOCl. So as a result, what we will be seeing is the product being formed is HCl and HOCl. So this is how you can remember this very well. So just break chlorine into one positive and one negative, combine it with one side on H positive and the other chlorine to the OH negative, and this is how the product you will be getting, HCl and hypochlorous acid, HOCl. Okay. Now this is an example of a disproportionation reaction. Now what is a disproportionation reaction? Well, disproportionation reaction, this is the auto redox reaction. What is the redox reaction? Well, in which there is oxidation and reduction taking place in the reaction. Auto means it is going to be self-redox reaction. In this, what will be happening is that the same substance is getting oxidized as well as reduced. So if you look at chlorine over here, we have chlorine in the elemental state. Here chlorine will be in the zero oxidation state. But in HCl, the oxidation state is going to be -1, and in HOCl, the oxidation state of chlorine is going to be +1. So 0 to -1, this is going to be reduction, and 0 to +1 increase in oxidation state. So this is going to be oxidation. So the same element is getting oxidized as well as reduced. Therefore, we call it as the disproportionation reaction. This is very frequently asked in the examination, so you should be knowing about it. The next similar behavior we will be seeing in the reaction of bromine with water also. HBr and HOBr will be formed. But here what will be the difference is that very less amount is going to be formed because bromine is not that very electronegative. So as the electronegativity of the elements is decreasing, the reaction proceeding in the forward reaction is also decreasing. So very less amount of HCl and HBr and HOBr will be formed. And when we see it in the case of iodine, same products you can write that it will be HI and HOI being formed, but here it is going to be just a negligible amount will be formed. The reaction will not be proceeding forward. What will be happening is actually we will be seeing that the opposite reaction is going to be a spontaneous reaction. So here what you saw was that fluorine and water, they react to form HF and O2. In case of iodine, the opposite reaction is taking place. HI and O2 will be forming water and I2. So here you can see H ions and I negative ions, that is HI, reacting with oxygen to form iodine and water. So this is what will be the spontaneous reaction. This is not going to be a spontaneous reaction, only negligible amount will be formed. So the next we have is going to be the D block elements. Well, you students must be asking, ma'am, what about the group 18 elements? We did not discuss about that. So group 18 elements, I have not written that down. They are all noble gases, and all you know is that noble gases, they are inert. So they will not be reacting with water. Okay, so we move on to the D block elements, and from the D block elements you have to just remember about the 3D elements only, not about the 4D and the 5D elements. That is not required. And here what we are going to discuss is what we've already discussed at the start of this lecture. All the D block elements, they are metals, and well, how are the metals reacting? All the metals which are going to be above hydrogen in the reactivity series, they will be reacting with water to evolve hydrogen. The reactivity series, I'm again putting it for you people. So here you can just see over here that we have manganese, we have zinc, we have chromium, iron, cadmium, cobalt, nickel. All of these, they are above hydrogen, so they will be reacting with water to produce hydrogen gas. Okay, and because here the elements, they are just lower down in the reactivity series, so all they will be forming is the corresponding oxides and hydrogen gas. And the elements like copper, mercury, silver, platinum, gold, they are also the transition elements, and again because they are below hydrogen in the reactivity series, so they will not be reacting with water. Okay, so the less reactive elements like manganese and zinc, they will be reacting with hot water, liberating hydrogen gas. For example, zinc, when reacting with water, this will be producing zinc oxide and hydrogen. And very less reactive elements like iron, nickel, cobalt, they will be attacked by steam only. The reaction, very important for you people, is going to be reaction of iron with water producing Fe3O4 along with that hydrogen, where Fe3O4 is ferrosoferric oxide, and ferrosoferric oxide, this is a magnetic oxide. So this is what you have to just remember for the D block elements. Then we move on to the last, the F block elements. So the F block elements, they are going to comprise the lanthanoids as well as the actinoids. But the actinoids, they are all radioactive, so we do not study about their behavior with water. So just what we will be discussing is the reactivity of the lanthanoids with water. So earlier lanthanoids, do remember that they are going to be similar to calcium in the reactivity, but with the increasing atomic number, they behave like aluminium. Okay, and all of the lanthanoids, they can react with water slowly in cold but rapidly on heating, forming hydroxides and evolving hydrogen. So they can react with cold water, but that is going to be a very slow reaction. But because they can react with cold water, so obviously they can form their hydroxides. So that is what you will remember. So the lanthanoids we can represent by the general symbol Ln. This will be reacting with water to form lanthanoid hydroxides. Do remember that the most common oxidation state for the lanthanoids is going to be the +3 oxidation state. So they will be forming LnOH3, and along with that hydrogen gas will be evolved. So that would be all for this lecture. We have discussed all the elements today of the periodic table, how they will be reacting with water, whether they will not be, whether they will be, and if they are, how they are going to be reacting with water. So the next the next lecture that we will be having is going to be on the reactions of the ionic compounds with water. So again, please do not miss that, because that is going to be very, very important for your examinations. All right. So all more lectures coming up on more tricks, more concepts, and more questions. And if you are having any doubts related to the things that we are teaching or anything related to chemistry, please do feel free, put your doubts in the comment section, or you can mail them to us at h2chemistry@gmail.com. So see you again for the next lecture. Please do subscribe, like, and share if you're liking. So see you again. Have a nice day. Bye bye.